All right, here we go. Lesson 7-2, multiplying polynomials. Reminder, before we get too deep into the algebra, from last chapter. When I multiply two monomials, like 2x to the fourth and 3x to the fourth, we multiply the coefficients, 2 times 3, and get 6. The x, obviously, x stays, and then 4 plus 4 gives me 8 for the exponent. Now when I add two monomials, first of all, the exponents must be the same, and then we just add the coefficients, the 2 and the 3, and get 5. And then our power, our exponent, stays as 4. So that's a little bit tricky to keep that in mind as you go through and do these problems. All right, our goal today is to use the distributive property to multiply polynomials. This distributive property can be done many different ways. All right. First one, there's not much vocab other than the acronym FOIL. The letters FOIL stand for first, outside, inside, and last. All right, and again, we are multiplying the polynomials many different ways. One way to think about this is if you think back about 12 times 12, notice there is a multiplication symbol in between here. If I were to just go 10 times 10 and 2 times 2, I would get 100 plus 4. And you would agree that 100 plus 4 is not 144. So clearly we must be making a mistake. And that's why we use FOIL, because not only must we do the firsts and the lasts, but we also must do the outside and the inside. So if I add on to this, the outside, which is 10 times 2, I get 20. Plus the inside, which is 2 times 10, I get another 20. And so we have 104 plus 40, so we have 144. Check. All right, so it works. FOIL does it for us. Here we go. We're going to do it on this next problem. X plus 2 times x minus 3. We're going to take x times x. We're going to take 2 times negative 3. 2 times x times negative 3. So we got all 4 of them. So we get x times x is x squared. I'm going to save the, sorry about that, the 2 times negative 3 for the very last. Okay, so I tend to put the first, and then I do the outside, and then the inside, and then the last. So negative 6, way out there. So that would be the last, 2 times negative 3. And the outside would be negative 3 times x, which is just negative 3x. And the inside is kind of easy too, because we just put the 2 in front of the x and call it 2x. Now we add up any pieces that are alike, apples and oranges, right? So the x squared stands alone, but the negative 3x and the positive 2x give me negative 1x plus negative 6. This trinomial is now stuck. It's of degree 2, so it's quadratic. We can't add any of those pieces together. This one I'm going to do slightly different. I could do FOIL. This one sometimes is called distribution, because you take the 2n and multiply it times the 2 other things. And then you take, or no, sorry, I'm not going to do this by using this. I'll do that in the last one. Or no, yeah, let's go ahead. Keep going, Mr. Larson. All right. So this one isn't technically FOIL because we aren't doing, we just paired them up slightly different. But it works out as long as you cover everything times everything. So I'm going to write this out because otherwise it gets a little bit too tricky. So there's the first multiplication I need to do, and 2n times negative 3. Be careful of that negative there. and then the negative 1/2 times n squared plus the negative 1/2 times the negative 3. All right, 2n times n squared. That gives me 2n to the third, because we add the powers, right? 2 times negative 3 is negative 6n plus 1/2 n squared, negative. And then lastly, negative times the negative is a positive. So this is 3 over 1. So we multiply those together and we get 3 over 2. Now, good news, bad news. We no longer have a trinomial. We now have a quadnomial, 4 terms. None of these terms add up. Now, it is not written in standard form, because though I have the highest power here and the coefficient here, these two middle terms need to flip around because that's a square power and it should go in front. So the last thing I'm going to do is just rewrite this using what we call standard form. All right. Last one. I'm going to use what we call the area model. So this is distribution, and this is called FOIL. FOIL only works on binomials. Pay attention to this area model one because it is kind of handy, and we're going to use it a lot when we get to 7.4 and 7.5. So in this case, I drew a 2 by 3 square. The reason I did a 2 by 3 is you'll notice I have a binomial times a trinomial. So I have 3 terms and I have 2 terms. Now what we do in this case is outside here is where we park or write down each of the terms. So I'll put an x and a 5. I'll put an x squared, a negative 3x, and a negative 2. And now we're going to multiply everything times everything, only I'm going to fill in the squares as I do that. So we'll take this times this, 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 and then that times that. X times x squared. Sometimes you might need to write that out because you need to think about it before you write out the answer. In this case, I get x cubed. X times negative 3x. I get negative 3x squared. This last one, pretty simple, just negative 2x. 5 times x squared. Well, that's just 5x squared. Again, 5 times negative 3x gives me negative 15x. And 5 times negative 2 is negative 10. So now my answer, I'm going to write down here in descending order. So my highest power is x cubed. Boom. My next highest power I see is an x squared and an x squared. These two things I'm going to add up. So 5 plus negative 3 is 2x squared. And then I'm going to add negative 15x and negative 2x, and I get negative 17x plus negative 10. There's my answer. All right, and here's a situation of where we might use this in the world of geometry. Example 2, I'm just going to set this problem up and then show you just kind of how it works and what method we could use on it. It says find the area. This trapezoid is labeled with a bunch of variable terms. So here I've got a distance of x. This distance on the bottom is 10 more than x, and the height is 7 less than x. So the area of a trapezoid, which you've probably forgotten from geometry days, is there. So I have to take 1/2 times the height, which is x minus 7. times base 1, which is x plus, so here's base 1, here's base 2, and here's the height. So plus x plus 10. All right, so in essence, I have 1/2 times x minus 7 times 2x plus 10. And then to finish this problem, we would need to multiply x times each of those pieces, -7 times each of those pieces, and then the resulting figures I'd need to multiply by half. Okay? I'm going to do that real fast because I think I can figure that out here. So I get 2x squared plus 10x plus -14x minus 70. These two combine together to give me -4x. And now we multiply them all by a half, and I get x squared plus -2x plus -35. All right, there it is. So a kind of a long lesson here on how to multiply polynomials.